We continue Unit 18 with solving more logarithmic equations. If each term of an equation has a log expression, condense each side to one log expression. Then use the following property to solve. If log base b of m is equal to log base b of n, then m is equal to n. Example 1. Log base 2 of x is equal to 2 times log base 2 of 3 plus log base 2 of 5. On the left-hand side, this is as condensed as it will get. But on the right-hand side, we need to move the 2 over to this side. Remember, we want to take care of exponents first when we condense, and then change any addition to multiplication or any subtraction to division. This will give log base 2 of x equals log base 2 of 9. Because when you move the 2 back, that becomes 3 squared, and 3 squared is 9. Plus log base 2 of 5. I still have two logarithmic terms on the right-hand side. There is a plus sign here. That means I need to change this to multiplication. So log base 2 of x equals log base 2 of 9 times 5. Log base 2 of x is equal to log base 2 of 45, since 9 times 5 is 45. Since the log and the base are the same on each side of the equal sign, I need to set the x and the 45 equal to each other and solve for the variable x. X is equal to 45, and this problem is done. Example 2. 3 times log base 2 of x equals log base 2 of 8. We take care of exponents first. We want to change any addition to multiplication and any subtraction to division. I have a 3 as my exponent, so let's move that back to its spot that it's supposed to be in, and that will leave us with log base 2 of x cubed equals log base 2 of 8. Notice the log base 2 are the same on each side, and that will leave x cubed is equal to 8. Now we need to solve for x. Since x is cubed, we could take the cube root of both sides. The cube root of x cubed is x, and the cube root of 8 is 2. So x equals 2. Example 3. Log base 8 of 48 minus log base 8 of x equals log base 8 of 4. The right side is already condensed, but we need to work with the left side. There are no exponents that need to be moved, so we need to condense our expression by changing the negative in this problem back to a division. Remember, the first term goes on top. The second term will go on bottom. Now the log base 8 are the same in both problems. I just need 48 divided by x is equal to 4. Now bring back some middle school math. This is 4 over 1. We cross multiply. 48 times 1 is 48 is equal to 4x. Divide by 4, and x is equal to 12. Example 5. Log base 7 of 3x plus 5 equals log base 7 of 8x minus 12. So this whole piece belongs to the log base 7 term on the left, and 8x minus 12 belongs to the log term on the right. We do not have to condense these expressions. Since the bases are the same, we just need 3x plus 5 equals to 8x minus 12. Solve for x by first subtracting 3x from both sides. 5 is equal to 5x minus 12. Now add 12 to both sides. And 17 is equal to 5x. Dividing both sides by 5 will give x is equal to 17 over 5, or 3.4. Example 6. This is a long expression, and I have to condense on each side of the equal sign to get one logarithmic term. Now, the log and the bases are the same on both sides. So we set the two terms equal to each other. We can also reduce the 6/4 to be 3 over 2, cross multiply, and then solve for x. Remember to distribute the 2 to each term and the 3 to each term inside the parentheses to get 4x minus 2 equals 3x plus 15. Subtract 3x from both sides, and then add 2 to both sides. And x is equal to 17. This concludes Day 2 of your Unit 18 foldable.